So to multiply radicals, your first step is going to be that you're going to multiply the numbers on the outside of the radical. Your second step is you're going to multiply the numbers under the radical. And then number three is going to be you're going to simplify. So there's technically a 1 on the outside, so you're doing like 1 times 1, which you don't have to show that. And then the square root of 3 times 15, which would be 45. Okay. I now want to see if I can take out a perfect square value, and I can. So the greatest perfect square value I could take out is 9. So 9 times 5 is 45. The square root of 9 is 3, so it would be 3 square root 5. My next one, I have imaginary 1 here and 1, so 1 times 1 is 1, so I don't have to write anything on the outside. And then the square root of 12 times 12 is 144. Square root of 144 is a perfect square, which is 12. So that shows you if you ever have two square roots with the same number underneath, when you multiply them together, it just basically gets rid of that square root and you're left with that number there. This one, you have two numbers on the outside, so you have 9 times 8, which is 72. You take the square root of 10 times 5, which is 50. You're now going to simplify that 50 because you can take out a perfect square value of 25, and that's the highest. I'm going to bring down that 72 because I'm going to multiply it. So 72 times the square root of 25 is 5. So 72 times 5 times the square root of 2. 72 times 5 is going to give me 360 square root 2, and that's going to be my final answer because I can't simplify it any further. This next one is going to be 3 square root 2 times 3 square root 2. So 3 times 3 is 9. Square root of 2 times the square root of 2 is the square root of 4. Notice the square root of 4 is a perfect square, so that's going to be 9 times 2, which gives me 18. Okay, that 2 on the outside means that you're multiplying by the same thing twice. So that's want to make sure that's where you extend it there. This next one, square root of, you're going to distribute the square root of 6 to the square root of 3 and the square root of 2. So the square root of 6 times the square root of 3 is the square root of 18. Square root of 6 times the square root of 2 is going to be the square root of 12. I'm now going to see if I can break these two down, and I can. The highest perfect square value that I can take out is 9. 9 times 2 is 18. So that is going to break down to 3 square root 2. I'm then going to see if I can take out a perfect square value on that 12, and I can. So that's the square root of 4 times the square root of 3, because 4 times 3 is 12. That's going to become 2, because the square root of 4 is 2, square root 3. They don't have any like radicals, so this would be my final answer here. Now, this last one, I'm going to distribute, and it's going to take 2 times 3, so that gives us 6. 5 times 6 is 30, so it's 6 square root 30. Now I'm going to put that minus sign because it's a positive times a negative, so 2 times negative 4 is negative 8. Square root 5 times 8 is 40. Looking at 30, I can't simplify that any further. There's no perfect square values I can take out, so now I'm going to look at 40. The highest perfect square value I can take out of there is 4. So the square root of 4 times the square root of 10 gives me 40. Bring down that negative 8. So that's going to be negative 8 times 2, because the square root of 4 is 2, and then the square root of 10. Negative 8 times 2 is negative 16, square root 10. I'm now going to bring this down. So 6 square root 30, and I can't go any further because those aren't like radicals, so that would be my final answer.